Okay, so number 36 on page 728. As you can see, it's a complex circuit. So the question is, what resistors go together? It actually looks exactly like the second example that we did earlier, right? So the total current leaves the power supply and flows this way. And when it gets to this junction, it has to split. Some of it will go through the first branch, the rest will travel and go through the second branch. So both resistors that are in the first branch are in series with each other. Both of the resistors that are in the second branch are in series with each other. And the two branches are in parallel. So if you put R1 and R2 together, and you put R3 and R4 together separately, you will end up with a simplified circuit that will be pure parallel. Okay, where this one is R12, and we can find it easily by just adding R1 and R2 together. And when we add R1 and R2 together, put a 2 up there, 64. And this one is R34, and we can get it by adding R3 and R4 together. It should be 96. Okay, and now it's a parallel circuit. V total was 144. And so I can find my R total by doing 1 over R total is equal to 1 over R12 plus 1 over R34. So 1 over R total is equal to 1 over 64 plus 1 over 96. Common denominator should be, I think, 192. Yeah. So this should be 3 over 192. And this should be 2 over 192, which will be 5 over 192. So R total will equal 192 over 5, 1938.4 ohms. Okay, so now we're ready to build our chart. So before we started, I put some, so this is, I made the columns for myself. So this will be 144. Our R total that we just found was 38.4 ohms. R1 was 26 ohms. R2 is 38 ohms. R12 was 64 ohms. R3 was 61 ohms. R4 was 35 ohms. And R34 was 96 ohms. All right. So now we look at our most simplified circuit. We realize that it's in parallel, and in parallel, the voltages are the same. So V12 should be equal to V34 should be equal to V total. So this should be 144 volts, and this should be 144 volts. So we can now find our I's. 96 goes into 144. 1.5 times amps, and 64 goes into 144 2.25 times amps. Oops, and we didn't find this one. 38.4 goes into 144 3.75 amps, and lo and behold, they add up to be 3.75, so all is good. So we finished our most simplified circuit. We now step backward and we say R34 replaced R3 and R4, which were connected in parallel. Which were connected in series. And in series, current is the same. So the I3 should equal I4, should equal I34, 1.5 amps. So this should be 91.5, 91.5 volts, 37, 40, 55, 52.5 volts. And when you add those back together, you get 144. All right, so then we go and we say R12 replaced R1 and R2, which are connected in series, and in series current is the same. So I1 should be equal to I2 should be equal to I12. So this should be 2.25 amps. This should be 2.25 amps. And when you multiply, you should get for this one 58.5 volts, and for this one 85.5, 0.5 volts, and you're done. Okay? So for a complex circuit, I want you to solve for everything, no matter what the question asks. That question probably asks something less than that. Solve for everything and you'll answer what the question asked. All right, the next one has 3 resistors, and so the current leaves the power supply, and when it gets to this junction, it splits. So these two are in parallel with each other, and then it comes back together, and the total goes through R3, which means R3 is actually in series. So you need to put R1 and R2 together to get R12, and then it'll be in series with R3. Okay, so R3 doesn't change, it's 6 ohms, and you need to find R12 by doing 1 over R12 is equal to 1 over R1 plus 1 over R2. So 1 over 25 plus 1 over 15, common denominator will be 75. So 3 over 75 ohms, plus 5 over 75, whoops, be good if I put the 75 in, ohms, gives you 8 over 75 ohms. So R12 is equal to 75 ohms over 8, which will be 9.375 ohms. Okay, so, and now it's pure series. So we go and we fill our numbers in. I didn't fill in what the total was, 25, I think it is, yeah. So 25 volts, and this is 9.375 ohms. 1 was 15 ohms, 2 was 20, oh, that was wrong, 25 ohms, 1, 2 is the 9.375 ohms, and 3 was 6 ohms. So when you add 6 to get the total, it's in series, so they just add up. So 6 plus 9.375, this should be 15.375 volts. No, ohms. And then to get the I, divide 25 by 15.375, and you should get 1.626 amps. All right, so then in series, current is the same. So I12 should be the same as I total, 1.626 amps, and so should I3, 1.626 amps. Now multiply 6 by that and get 9.756 volts. Multiply 9.375, that's just nasty, and get 15.444 volts. Okay, and now 1 and 2 were in parallel. They were replaced by R12. In parallel, the voltages are the same, so V1, V2, and V12 should all be the same. So this should be 15.444 volts. So should this, and now to get your I's, just divide by your R's. So this one's going to be 1.016, and this one's going to be 0.61. And you're done. Easy peasy. Okay, so the hardest part is knowing which ones to put together. And then after that, hopefully you simplify the R's going one way, fill the chart in going back.